Hello everyone, in this video we are going to see about the evaluation metrics. The evaluation is upon the model, how the data is, how precision the data is on the model. Okay, so let us see first of all what is the evaluation requirement. Model evaluation requires independent data sets to estimate the generalization error. And classification, so we have two types of evaluation method, classification and regression. So in the classification we have the methods called accuracy, confusion matrices, precision recall, and AUC, area under the curve. And in the case of regression, helps for the continuous variables. There we are using the RMSE and the MAPE for method for the continuous variables. And we have both online evaluation and offline evaluation. And online evaluation assesses the live performance and business goals. Let us see one by one. Now let us see first of all reality gap between the online and the offline evaluation. So offline is, it is in the lab, as means we are giving sample data and then we learn the model by the training the model by using the data. Okay, so that is evaluation during development, that is development of the model. The goal is maximum precision on training or validation data. In isolation, the model seeks mathematical perfection. So we have some mathematical accuracy terms and we evaluate based upon the mathematical perfection. Okay, so in the case of online evaluation, we evaluate after deployment. That means after we make the model run for the necessary situation. So metrics shift to business constraints like budget, treatment value, user satisfaction, all those things. So it requires the feedback loops. That means human or automated feedback is analyzed and again the metrics is evaluated. That is called as an online. Okay, so here we are giving the user is giving so many context is given here. So the user give the feedback. There are some real world problems, real world loop. There is the feedback loops, and what is the context the data is used, and what is the treatment value. So many factors are considered, and that is evaluated on the online. That is, it's a wild. Okay, so and the golden rule for independence is the danger of training data optimism. What is optimism is we always choose one set of data and try to bring the good results. So that is not the proper case. Okay, so it is like training data is the textbook where generalization error comes when we use only the tested data. That is the exam. So if at all we wanted to check whether the student is perfect in the whole book of information, so that is called training data, where he or she is supposed to learn the whole book, but the tested data is the as per the questions are come, the answer must be given. So accordingly the mark also will be scored by the student. Okay, so that is means they are having some subset of the data only for testing. That is the generalization error. Okay, so a model evaluated on its training data is optimistic. It has memorized the answers. To find the truth, we must simulate new data using techniques like n-fold cross-validation. Often the data used is more important than the algorithm choice. What does it mean is we have many algorithms to do the evaluation, but the data used is very, very important. The based on data only the algorithm is going to give the results. Okay, and then the classification toolkit. So we have as we know, we have two major methods, classification and regression. And under the classification, we have the following tools. Um, that is the accuracy, precision and recall, confusion matrix, logarithmic loss, and area under curve. Okay, so here what is the task here is assigning a specific label to an input, because as a classification we know it is a it's one of the supervised learning technique. So you are going to assign a label to the input. Okay, so different problems require different lenses. Choosing the wrong tool obscures the truth. So what does it mean is we should be able to choose the proper algorithm for the proper data with the proper data. Okay, so the next slide speaks about the one of the term, which is the accuracy, one evaluation method. So what does accuracy says is the simplest metric calculated as percentage of correct predictions over the total number of predictions made. So the formula given is TP plus TN. So true positive and true negative divided by total observations. Okay, so that is the accuracy. And in accuracy is very simple. It deceptive means it is not perfect. So we are going for a next method called per class accuracy. Okay. So what do they say is, if 90% of your data is class a model that guesses class A is very is every time is 90% accurate but 100% useless, because we are giving only class A data. If you mix all the classes of data and your model is finding the class A, that is good. But you are giving only class A data, then answer also will be class. Okay, so that is what the per class accuracy comes into existence. What does it mean is, this is useful for disordered problems where one class has significantly more examples than the other, ensuring that a model performance on minority classes is not overlooked. That means all the classes are considered in an average case. So real world example, 80% of accuracy on positive class and 40% on negative class. So raw average is 60%. Okay, that is 80 plus 40 by 2. It is 120 by 2 is 60. So that means we can say the per class accuracy is only 60%. Okay, use per class accuracy for distorted problems to prevent the majority class dominance. And then about the confusion matrix. So the confusion matrix have the following information like predicted positive, predicted negative, actual positive and actual negative. So the four cases are considered, and based on these four cases the classification is done. Okay, so what does the confusion matrix says is, this provides a detailed breakdown of correct and incorrect classifications. It identifies true positive, correctly predicted yes, and two negatives correctly predicted no, as well as false positives and false negatives. Okay, so we have the four things: actual positive, actual negative, predicted positive, predicted negative. So if it is actually positive, it is also corrected as positive, it is called true positive. It's actually positive but it is not predicted as positive, it is called false negative. Okay, and then we have actual negative but it is predicted as positive, which is false positive, and actual negative but it is predicted negative means true negative. This is the case. And here the example of a breast cancer diagnosis is given. In this case of breast cancer, if it is false positive, it is cause stress, because a person having no disease but giving us it is confirmed, that is it causes stress. Okay, and a false negative, here the case misses a life-saving diagnosis. A person may have breast cancer but it is considered as negative means that is the case is missed. That means he is not found to be with the cancer, means they won't treat, so it will miss a life. Okay, so the cost of error is rarely equal, because this every error has its own consequences. Okay, so now next term is about the precision and the recall. Precision and recall evaluates how many predicted items were actually relevant, while recall measures how many relevant items the model successfully identified. So we have a model, so the picture clearly says that the precision is the quality. Okay, so how many selected items are relevant? That means TP by TP plus FP. Okay, and in the case of recall means how many relevant items are selected. We have many items, that is the quantity. Okay, so you are choosing something, how much it is good, that is the quality. We are going to choose relevant items as the quantity. Okay, so it is given by TP by TP plus Fn. Okay, so this gives the precision and recall metrics. And the next evaluation metrics is the when we go between precision and recall, we have some issue here. When you need a single number to balance precision and recall, an arithmetic mean is insufficient because it tolerates extreme imbalances, which means that arithmetic mean is the arithmetic average. If it is precision and recall are the parameters, which says about the the definition says that the quality and the quantity of the items chosen. Okay, so now the arithmetic mean will not give the proper balance, it will give the in its extreme imbalance. So what you do is you have to go for the F measure. F measure uses the harmonic mean to penalize models that cheat by maximizing one metric at the expense of the other. That means we should be in an average position to consider both the precision and the recall. Okay, And then next is about the specificity. What is specificity is performance regarding incorrect classifications. So here the same thing we have seen about the confusion matrix over here. So actual class is P and predictor class is it's true. So true positive. So actual class is P, but it is predicted as negative. So it is false negative. Okay. And actual class is N, it is negative, but it is given as positive. Predicted positive means false positive, and the other case is the true negative. So specificity measures the model's ability to correctly identify negatives. It is the recall of the negative class. So we can also say that specificity is the recall of the negative class. Okay. So Tn by Tn plus Fp. And next is about the logarithmic loss. Next parameter, next metric is logarithmic loss. This is used for continuous probability predictions. It isn't enough to be right. The model must be confidently right. Okay. So it has some penalty where the penalty helps to get the prediction. Okay, for example, this chart gives the effect of the confidence, how the confidence is measured based upon the that means the how the loss affects the confidence. Okay, so if it is a low loss means it is correct and confident. Okay, that means the prediction is correct and confident means is only low loss, and then wrong and uncertain is moderate loss, and wrong and confident is extreme loss. Okay, so the thing is wrong, but it is extremely, we are confident that it is right means it is a loss only. Okay, so extreme loss. So the formula says that logarithmic loss is equal to minus of 1 by n summation of ya into log of pi plus 1 minus ya into log of 1 minus pi. That means it considered log of pi is the positive success case and log of 1 minus pi is the failure case. Okay, so it considers the average of all the cases, both the failure and the success cases. So next is about the area under the curve, AUC, or the receiver operating characteristic, which is the ROC. So this ROC, what it does is it plots between the sensitivity versus the specificity. Okay. So here this that is sensitivity versus specificity. So we are having false positive rate and true positive rate. So the area under the curve indicates a better trade-off. So this is only this much is better. This area need not be considered. Okay. So and next is the regression. So far what you have seen is all about the classification toolkit. Now the regression toolkit. So when we go for regression is if the answers record are continuous variables rather than labels, the evaluation metrics change. That means you have to go for the continuous type of metrics. That is the two major things are given, RMSE and MAPE. So RMSE depends on the standard distance. RMSE means root mean squared error, and MAP is based upon the robustness, is the medium absolute percentage error. Okay, so this is the classification technique where we have numbers to label, and here it is a continuous thing, which is a regression. Okay, now we are no longer sorting into buckets. We are measuring the distance between the prediction and the reality. So how much correct our data is working, and reality what is the expected value and what is the observed value. That is the distance between the prediction and the reality. And then about the root mean square, the definition is it calculates the average Euclidean distance between the predicted and the actual values. It is the industry standard. So what is the weakness of this RMSE method is it is highly sensitive to outliers. What is outliers is the cases which not considered inside the group what we consider. For example, all these blues comes in this straight line very closer or little away, but this orange dot red dot, this is actually far from the this area. It is too far. That means it is outlier. It is not inside the group. It's the outlier. Okay, it lies outside. Okay, so that single red dot is skewing the entire error score significantly. So now because of this deviation, long deviation, the average, the formula will give a, it will skew the entire error score significant, means the error rate will be high because of this one deviation by by few values. Okay, so RMS is equal to square root of summation of actual minus predicted the whole square. The graph is between predicted versus the actual values. Okay, so next measure is about the MAPE. This is based upon the robustness. And what is robustness is the speed at which the data is going to react for the real world data. Okay, so the median absolute percentage error in real world data is dirty. This is obvious. We have to clean the data before we process it. So map uses the median rather than the mean. Okay, allow it to ignore the extreme outliers that would break RMSE. So it is an improvement in the RMSE previous method. So it always ignores the outliers. Okay, extreme outliers are ignored. So that is the formula MAP is equal to median of actual minus predicted divided by actual. Okay, so when you need to answer, are predictions generally within 5% of actuals? So this says about the median values. Okay, so the final slide, it says about the whole framework, the evaluators framework. What is the data profile? So based upon imbalanced classes, we go for use per class accuracy, false negative or dangerous, that case you are going for a prioritize the recall. If it is confidence check, go for use logarithmic class. If it is extreme outliers, you go for map method. If the data is standard regression, use RMS. So based upon the data nature, we can use the right metric. So right metric is not a choice, is not a mathematical choice, it is a business choice. That means we cannot go only by the formulas. We always also go by the real situations. So that's all for this concept of the evaluation of metrics. Hope it is easy and simple to follow, and thanks for watching.